Hello students, welcome back to my channel JB Physics. In last lecture we have discussed the vertical circular motion when mass is tied to a flexible string, right? Now in this lecture we will discuss the vertical circular motion when the mass is tied to a rigid rod. When vertical circular motion when mass is tied to a rigid rod. If you consider this as a rigid rod and mass is tied to this rigid rod, and if we make the vertical circular motion, see what will happen if we come to the uppermost position, bottom position and middle position, right one. But when we come to the uppermost position, it is clear that we can stop there. There will be no any tension like that string, and here the velocity of that particle can become zero here, right one. No flexibility is there, nothing is there, no tension is there. Only if we stop here, all the energy possessed by this particle which is tied to this rod will be the potential energy, right one. This circular motion means when we consider the circular motion of that particle when it is tied to a rigid rod, right one, this is rod and particle is at this position, that is uppermost position. Length of this rod is as the radius of the circular path, and the height from reference position, that is this bottom position, r plus r, that will be 2r, right one. At this position A, the potential energy will be mgh, that is mg into 2r, correct. No kinetic energy will be there, that particle will get totally stopped. Velocity becomes zero, that is Va will become zero. Only potential energy will be possessed by the body. And during that motion, when it comes to the bottom position, that whole potential energy get converted into kinetic energy at position B or at bottommost position, right one. No potential energy will be there at position B because reference point height will becomes zero. Therefore, this total potential energy, that is mg2r, will get converted into kinetic energy by law of conservation of energy. Therefore, mg into 2r, I can write 1/2 mvb square. All this potential energy will get converted into kinetic energy. This 2 will become multiply here, m will get cancel. Therefore, 4gr is equal to vb square. Therefore, Vb is equal to under root 4gr, and that will becomes 2 under root gr. This will be the velocity of the particle when it is at bottommost position. This is uppermost position, this is bottommost position, this is middle position, right one. So at this position, that velocity will be totally zero. In that flexible string, when we have considered the vertical circular motion, that velocity was Va is equal to under root Rg, right one. But in this case, that is in case of a rigid rod, that velocity will be zero. Va will be zero. And when there is a bottommost position, that velocity will become 2 under root Gr. You understood? When we consider the rigid rod, the velocity of the particle at topmost position, that will be 0, and at bottommost position, that will be 2 under root gr. Similarly, you can derive the velocity at middlemost position, that is we have considered that point as a C, and that Vc will be under root 2gr. We can easily calculate this velocity Vc is equal to under root 2gr. There will be no any question depend upon this derivation, but you have to know these values. You have to learn these formulas. You have to remember these formulas when the particle is or that mass is tied to a rigid rod. That time Va will 0. That is velocity of the particle at topmost position, that will be 0. In case of flexible ring, that flexible string, it is Va is equal to under root Rg. When we consider the bottommost position, in case of a flexible string, that velocity was under root 5rg. But in this case of a rigid rod, that will be Vb is equal to 2 under root gr. In case of a string at the middlemost position, that velocity was 3rg, under root 3rg. But in case of rigid rod, that velocity will be under root 2gr. You have to remember these formulas. Only maybe there will be objective type question in this case, or also they can ask any numerical depend upon that. But no derivation will be there. Okay, confirm, no derivation will be there, but you have to remember these formulas. That is velocity at bottommost position, it will be 2 under root gr. At middlemost position, that will be under root 2 gr. And at the topmost position, that is Va will be 0 in case of a particle when it is tied to a rigid rod. Okay, you understood these three values of velocities? Okay, so we will consider the next point of this chapter, that is rotational dynamics. It is when a body or when a vehicle is traveling along a convex bridge. We have to consider that case now. It is okay? Okay. When we consider a vehicle, it is moving on a convex bridge. Vehicle moving on a convex bridge. What will be the velocity of that vehicle when it is at topmost position of that convex bridge? Means if this is a convex bridge and if vehicle is present at this position, we have to consider or we have to calculate the formula when this vehicle is at topmost position. We have to find out the velocity of this vehicle at this position. Okay, so we have to consider now first FBD for this vehicle. What will be that? All the forces acting on the body. So wet force mg will be in downward direction, normal will be in upward direction because it is at contact with the surface at this position. In case of vertical motion of that particle, it is tied to a string, there was a tension, right? But here we are going to consider a vehicle is moving on a convex bridge. At that time, there will be normal acting in a upward direction and wet force mg is acting towards the downward direction. If we consider this as a circular motion, here the centripetal force will be the net force due to this wet force mg and normal reaction acting on that body. For the circular motion, if we consider this as a circle total, then the centripetal force required for the motion of this vehicle along this convex bridge, circular convex bridge, at that time the centripetal force, that is mv square by r, is nothing but the net force due to this normal and this wet force mg. What will be that? That will be mg minus n. Right one, mg is in downward direction, normal is in upward direction. So net force which is towards the center, it is centripetal force mv square by r, and it is nothing but mg minus n. Now here this normal is only to maintain the contact with the surface, right one. So we can take that normal approximately equal to 0. See, if V is going on increasing, this N will goes on decreasing. Then what will be the maximum speed of that vehicle at this topmost position? That will be mv square by r is equal to mg only, because this N will goes on decreasing. The use of this normal reaction to only to remain, only to make the contact of that vehicle with the surface. And this n will approximately equal to 0 at this position. Therefore, we can write mv square by r is equal to mg. This m will get cancelled and v square is equal to rg, that is v is equal to under root rg, and this is the formula for the maximum speed of that vehicle when it is traveling on the convex bridge and it is present at the top position of that convex bridge. Not here, not here, not here, not here. We are considering the topmost position of this convex bridge. At this point, the normal will be present here only to make the contact of that vehicle with the surface. And for that maximum speed, this n will goes on decreasing. That this n can be approximately equal to 0. Therefore, mv square by r will be equal to mg. Mm get cancelled and we get the value as v is equal to under root rg. So this is the formula for vehicle when it is moving on a convex bridge. You understood these two derivations or these two formulas. There will be no any question for this vehicle moving on a convex bridge, means derivation I am telling. If there is a numerical depend upon that, you have to use all these things. Okay. So if you like this lecture, if you like these points which I have explained, please like, share and subscribe my channel. And also if any doubt regarding to these points or also another point, you can comment me in the comment box. I will give the answer for that. Okay. Thank you.